5.1, perpendicular and angle bisectors. We have already spoken about these. Who remembers what the word bisect means? Bisect. You know it. Yeah. Bisect means to cut in half. Very good, because bi means two. So if I cut something in half, what does that mean about the two pieces that are left over? They're equal. They're exactly the same. Very good. So we're going to start by talking about perpendicular bisectors, then we're going to talk about angle bisectors second. So first one is perpendicular ones. Huh? There are easy and hard sections in this chapter. How about that? Okay, bisector means cut in half. Who remembers what perpendicular means? Here's parallel. Perpendicular is like this. It's what kind of angles? 90-degree angles. Does the symbol for perpendicular is just an upside down T. Okay, so instead of me writing the word perpendicular every single time, you're just going to see an upside down T. That means perpendicular. Okay, so when I cut something in half and it's perpendicular, essentially all that's happening is I'm creating two things that are exactly the same. Okay, so we're going to draw ourselves a nice big triangle. I'm going to call this triangle A at the bottom on the left, B on the right, C at the top. So I've got a triangle there. And now I'm going to create a 90-degree angle and cut it directly in half. So I'm going to go straight down from C. And this is now going to create two smaller triangles that are exactly the same, which we've seen before. Okay, now it also creates 90-degree angles. I'm going to call this D at the bottom here. Where would my 90-degree angle go? At which letter? D. Angle D, yeah. So if I put a 90-degree angle on the right, well, guess what that means is on the other side, if I flipped it over to the other side. Because these are two congruent triangles. Another right angle right next to it, yeah. Right, so now I've essentially just have two smaller triangles that are exactly the same, except they've been reflected. They've just been flipped. So which one matches up with angle A if I flipped it over the other side? What matches with angle A on the other side? Angle B. And then this angle C on the left matches up with angle C on the right, right? Everything matches up. It's just flipped to the other side. Okay, so this piece right here, CD, is called the perpendicular bisector because it cuts the triangle in half. Okay, so when you cut this triangle in half, a number of things happen. You have some segments that are exactly the same. So which piece matches up with side AC? I flipped it over to the other side. BC, very good. These two sides would be exactly the same. So side AC would be congruent to side BC. Okay, another pair of sides that match up. Which side would match up with side AD? Flip it to the other side. DB, good. On the other side. Very nice. So AD is congruent to BD. Right? All these sides are exactly the same. All the angles are exactly the same. These two are the important ones. And the last important thing is that at angle D, you have right angles. Angle D is a right angle. Okay, so if I'm looking at this picture here, let's just say this side right here was like 10 inches. What does that mean this side over here is going to be? This side's 10 inches, what would this side be? 10 inches. If this side's 2 inches, what would this side be? 2 inches, right? Everything should match up and be exactly the same. You're just taking a triangle, cutting into 2 smaller triangles that are congruent. All right, so we're going to do one example for this problem. All right. So we're going to start with a nice big triangle. Same kind of shape. Draw nice and big so you have enough space to write into it. And I'm going to call this triangle E on the left, F at the top, and G at the bottom. Okay, so there's my nice big triangle that I start with. I'm going to bisect it, so I'm going to cut it right in half. Ooh, kind of. That was bad. I'm going to call this part H at the bottom. So this should be a 90-degree angle down here. And which one is your bisector? Which segment cuts it in half? Perfect. FH is my perpendicular bisector because it cuts my whole thing in half. All right. So I'm going to give you 2 pieces of this triangle, and we're going to solve for the unknown piece. So the first one I'm going to give you is this piece right here, EH. So this segment is 8x minus 37. And then the other piece I'm going to give you is HG right next to it, and that is 5x plus 17. So what I want you to do is you're going to find x, and you're also going to find EG. You need 2 pieces. You're going to find x and you're going to find EG. All right. So I know that FH cuts this triangle in half. It makes 2 congruent triangles. So you should have some pieces that match up. Which piece matches up with EF over here? If I flip it over to the other side, which one matches up? With EF. FG. Yep, there you go. Those 2 pieces are exactly the same. Well, this piece here, EH, which one does it match up with? Flip it over to the other side. EH matches up with which side? HG, right next to it. So these 2 sides are congruent. They're exactly the same. So if they are the same, what am I going to do with these 2 equations? They're the same. What do you do if 2 things are exactly the same? Set them equal to each other. Perfect. I'm just going to take this equation, set it equal to this one because they're exactly the same. So I'm going to do 8x minus 37 equals 5x plus 17. And then it becomes algebra. Can you solve that algebra problem on your own? Yes, you can. Give it a try. Let's see if we get the same answer. Get all your x's to one side, all your numbers to the other side. Always move your smaller x. Why? Okay. Okay, can I give you something to do outside, which is going to be kind of weird? I'm going to give you my pencil sharpener. You're going to pencil sharpener. Give me 1 second. I know it's strange, but I just don't want it to go off while everybody in here is trying to talk. I'm trying to talk. Be careful when you lift it so that there's stuff in it. So just plug it in outside. And the only colors I really need are, what's left? Purple, pink, gray, and black. Thanks. All right, so the first thing you should have done was what? The first thing? What's the first thing you should have done? Minus your 5x on both sides. You get 3x minus 37 equals 17. What would have been your next step? Add 37 on both sides. You get 3x equals 54. And then what's your final step? Divide by 3. You get x equals 18. Okay, so we did the first part of the problem. Second part of the problem says find EG. Now, here's EG from here all the way down over to here. What do I have to do? What do you think? How am I going to solve for that whole length? What would I have to do? Well, ooh, I don't know. Add 18 together with what? Well, that would be if this just said x and x, then I'd say yes. I can't add it to 180 because these don't have degree symbols next to them. Once you solve for an x, what should you normally do with it? What can I do with that x? I can plug it in. Yeah, I can substitute it. So I can take this 18 and instead of having an x right here, instead of doing 8 times x, I can do 8 times 18. And I can get what the length of this one side is right here. Okay, so we're going to take it, we're going to plug it in. 8 times 18. And then we're going to subtract 37. That's going to give me that one piece right there. All right, what is 8 times 18? Dan, can you turn your music off, please? Can you turn your music off? I don't really want to listen to it. Thank you. 8 times 18 gives me 144, and if I subtract 37 from it, I get 107. Okay, so this piece right here is 107. What does that mean this piece right here is? With having to plug anything in. It's 107 again. Good. So this piece is 107. This piece is 107. So if I wanted to know what the whole thing was, what would I have to do? Add 107 plus 107. Good. So your final answer is EG is 214. So once you've solved for x, you're just taking it and plugging it back into the equation. All right, questions on that one? Good. All right, now the next one we're going to do one example of is a angle bisector now. So I'm going to flip to a new page so I can do both the notes and the example on one page together. But if you have enough space, you can do it on the same page. It's up to you. Now we're going to do an angle bisector. So instead of cutting a triangle in half, now we're just going to cut an angle in half. So I'm going to draw a nice big angle. I'm going to call it angle BAC. Okay, so I've got my angle A, and I'm going to cut angle A in half. So what does that mean about the two pieces of angle A? They're going to be what? If I cut it in half, they're going to be congruent. They're going to be exactly the same. Very good. So AD bisects this angle BAC. AD bisects angle BAC. So I should have two angles that are exactly the same. And it's the two angles right at angle A, right here. So these two small pieces should be exactly the same, right? So if the whole thing was 100 and I cut it in half, what would each one be? 50 and 50, exactly. So this angle right here is angle BAD. That's this top one, BAD. And it is congruent to the angle right at the bottom, CAD. All right, so those two pieces of the angle are exactly the same. And then there are two more parts that happen in this picture. Because it is a bisector and it is perpendicular, it creates 90-degree angles. So from B to D, that will create a 90-degree angle. So segment BD is perpendicular to segment BA. And because this is bisected, the exact same thing happens on the other side. So from D to C, I create another 90-degree angle. So DC bisects AC. So essentially what happens when you've got an angle bisector is now you just have two triangles that have 90-degree angles in them. But again, everything is exactly the same. So like this segment right here, BD, matches up with this segment DC on the other side. Same with AB would match up with AC, right? You're just creating multiple triangles that are exactly the same. Okay, so we're going to do what? So it's essentially the same thing as this one. It creates two triangles that are exactly the same, except this time the only thing that's different is instead of my triangles having 90 degrees right next to each other, they're 90 degrees across from each other. Okay, so we're going to do one example and then we'll be done with this. All right, so we're going to draw a nice big angle. Again, it's going to look literally the same picture as this one. We're just going to do different letters. So we're going to start with a nice big angle. Wow, that was terrible. And I'm going to call this A, B, C. Ooh, okay. All right, thank you. And then we're going to bisect it right down the center. Wow, I am so off today. With D. Oh, I am sorry. But I'm not that sorry. Okay, my triangles look horrible. I do apologize. It's the same picture as this one. I just changed up the lettering. So sorry about that. Okay, so these pieces are the same. And this time I'm going to give you two angle measures. So the first angle measure I'm going to give you is the top one of angle B. So this angle right here is going to be 6x plus 13 degrees. And then the angle right below it is going to be 16x minus 7 degrees. Okay, my bisector is BD. It goes straight through the center. So BD bisects angle ABC. All I want you to do this time is find x. Okay, so I've given you two pieces of the bisector, two angles, and all I want you to do is find x. Now, what do you know about those two angles? If they have been bisected, what does that mean about the two of them? They're equal. They're exactly the same. So I want to write an equation that says these two angles are exactly the same. How would I write that as an equation? Perfect. Just put an equal sign right in between them. 6x plus 13 equals 16x minus 7. And then all you have to do is solve for x. So I'm going to let you try that one. And then we'll come together. We'll see if we get the same answer. All your x's to one side, all your numbers to the other side. Leave your smallest x first, always. It'll make your life easier. And remember, you're talking about an angle. So you should have what with your answer? If it's an angle. A degree symbol. Okay, did you get x equals 2 degrees? Fantastic. 2 degrees is your final answer. All you have to do is find x for that problem. All right. Now, what I just passed out to you is what you're going to start, right now, and you're going to finish up tomorrow. You'll have the whole class period tomorrow. But what I've just passed out to you is all perpendicular and angle bisectors. So for every single one, it should be very easy because the triangles are congruent. All you're going to have to do with your equations is set them equal and solve for x. It should be very simple. Yes. So as you go through each problem, here's what's going to happen. It is a chicken, and it's actually a turkey because it's Thanksgiving. So you're going to find the value of x for each one, and then you're going to find your answer on the back and color it whatever color it's given to you. So if you do number 1, right, you find the value of x, you set your equations equal, you get, let's say, x equals 10. That means everywhere you see the number 10, you're going to, can someone grab the door, please? You're going to color it green. So you flip to the back. If you got x equals 10, you say, oh, there's all my 10s. You're going to color them all green. Obviously, that's not the right answer. So don't do it. Anyway, you're going to go through. You'll solve each one. You find your answer on the back, and you color it. What happens if you don't see your answer on the back? You did the problem wrong. Yes. Okay. So it should be relatively easy. The only thing you have to be very careful of is some of the questions ask you for x, some of the questions ask you for a side length. So if they ask you for a side, that means you're going to have to plug in your equation. Okay. So we've got about 12 minutes right now. I think you can get through at least a couple of the problems. Just get some done today. And then we'll have the entire class period tomorrow to work on this assignment. So you are cool to either start with the math. You can do math and color. I don't care how you decide to do it. But you've got today, you've got the rest of tomorrow as well in class to do it. Okay, it'll be due on Friday. All right, so go ahead. You guys can get started, and I will come around and I will help you out as you need help.